In question 7, again we have tensile stress, tensile strain relations. A cylindrical rod of copper is given with a yield strength of 240 megapascals, load of 6,660 newtons is applied, length of the rod is given, and what must be the diameter to allow an elongation of 0.5 millimeters. Also calculate the modulus of resilience. Let's start with the allowable diameter calculation. So we have 110 gigapascals. Yield strength is given. Applied load is given. The length is given. What must be D so that this is the elongation. So if we assume that we are in the elastic region, we have the Hooke's law that relates all these expressions. In Hooke's law, the stress and strain are linearly related. The stress is P over A0, strain is delta L over L0. And since it's cylindrical, this expression is pi over P over pi times d squared over 4, area of a circle. So we can leave delta L alone. We can leave the diameter alone to have an algebraic expression for the diameter calculation. So 4p over pi d squared is E times delta L over L0. Then leave the squared alone. What you will get is 4 times the load times L0 divided by pi times Young's modulus times delta L. And square root of that is going to give you the actual diameter. If you substitute these expressions for P 6,660 newtons, for L0 we have 380 millimeters, for E we have 110 times 10 to the power 3 megapascals, for delta L we have 0.5 millimeters. So if you check the units, all units cancel out, on only millimeter square is left, and square root of millimeter square is millimeter, and the numerical value is 7.62 millimeters for the allowable diameter. Also, let's calculate the second part of the question here, resilience. Sigma y squared over 2 times Young's elastic modulus, 240 megapascals squared divided by 2 times 110 times 10 to the power 3 megapascals. That will give you 0.2618 megapascals. And from previous questions we know that 1 megapascal is 10 to the power 3 kilojoules per meter cube. If you substitute that in, then modulus of resilience is 265.8 kilojoules per meter cube.